in inglese, lo facciamo sta
Ah,
cosa.
okay.
So you classify, you want to you want to train two classifiers.
Yeah. The first one is, let's say, traditional CNN that given the image of a person in input, it, it tells you whether it is a player or not. And by not, I mean it can be he can be an umpire, a referee, a person from the audience, and whatever is not a player.
Yeah.
And this is the first.
Okay. Then
The second model basically is Siamese network that given in input two images of people tells you whether they are, let's say, the same, they are from the same cluster or not. And we would like to identify three clusters here: team A, team B, and all the rest.
okay, where group and here group is, you said, is team A, team B, and then
At this stage, all the rest. Eventually, in future, referee, umpire, and so on.
okay. Now, how many labels do you need for C1? Davide.
Valerio, do you think that players patches and non-player patches are roughly the same numbers in our dataset?
Maybe there are a bit more players.
Okay. Yeah. For this classifier, I think we would need no more than 20,000.
Hang on. How many labels? Like two, player versus not player, or
Yeah.
Yeah,
For the first one, yes.
Yeah. It's a binary classifier.
So type of classifier, binary. Okay. What about C2? How many labels?
C2, in theory, 3.
No, Vale, we need more. I mean, we have 3 labels for each match, right?
Yeah, three labels per, because the annotation for classifier 2 must be done for each match separately.
Okay, so how many labels? How many?
Yeah, for each match at this stage, even 3 labels are enough.
So it's team A, team B, and rest. These are the 3 labels.
Yeah.
Yes, but since the cost is the same basically.
So they have to label team A, B, or rest.
And, yeah.
Okay. And here, what kind of classifier are you training? What is the type?
Yeah, it's a Siamese network. So you're giving an input to different images, and the network has to recognize if they belong to the same team or not.
Okay. So what is this deep or not? What is the approach?
Yeah, it's a two-stream convolutional neural network.
So this is deep. What about this? C1, sorry.
Yeah.
Is it deep or shallow?
No, it's
No,
different.
no, convolutional network.
So this is a CNN that you run on each patch.
Yeah.
And this is a SEMIS network, same approach, same CNN.
Yeah.
Yeah, it takes two inputs, the second classifier, actually.
And how do you measure the performance? How will you measure the performance? What measure of performance will you cross-validate?
Well, for the first one, I think it's simple. F1 or, yeah, F1.
Okay, for the second one, Davide?
Um, the loss of the semis network technically is called contrastive loss, but it's just the loss. I think that the metric we have to consider is like a multi-class accuracy.
Okay. All right, so now we have all the elements to determine how many training samples we need, right? So what I'm encouraging you to do is step 1, define problem. Step 2, parameters of the problem. Step 3, determine how many labels I need, right? For instance, what is the most difficult problem, C1 or C2? Based on
Yeah, C2.
yeah, C2 is the most difficult, right? So this is the most difficult. So if we look at C2, is the most difficult. So how do we, if you had a smaller budget, what would you
Yeah,
where would you allocate?
I would differentiate the most over the different teams. More teams we have, the better it is. I think.
Okay, so this is high and this is medium. Okay. Now, at a push, what is the minimum amount of labels that we need to test for testing purposes?
For
Let's think
testing.
in terms of matches first.
Currently, all the models I made have been tested on only 2 matches, but maybe we can consider some more.
Okay, so let's say that we need at least 20. We need at least 10 matches. Okay.
Only for testing.
Only for testing, yes, 10. Okay. And for training purposes, let's say that we need more. We need 20. So the double of test. And if we have very little budget, we could downscale this to 5 and this becomes 10. Okay. Do you understand my logic? I'm trying to come up with a number based on the kind of problem that we are resolving. Okay, so if we have 10 matches for test and 20 matches for training, how many patches do we realistically need for a binary classifier where we already know F1 is, where accuracy is 50%, I think, the baseline?
For C2, maybe is 3, because we are identifying 3 groups. 33, because we are identifying 3 groups. Team A, Team B, and Team A, Team B, and rest.
So if these are 10 matches, let's say we take this decision in a different way. So we take this decision by looking at, so a match contains how many minutes?
Let's do 90 minutes.
A match is 90 minutes, okay?
Yeah.
So at the moment, how many, you take one frame every 6 seconds?
Yeah, let's do 7 seconds.
Okay, let's say 10 seconds, because it's easier for me to calculate. Because here we have, say, per 954, is it 5,400 seconds? Yes, 6 per 954, and then divided by 10, it means that you take 540 frames, which means that you take 540 poses.
No, you have to consider that for each frame there are at least 10 people on average.
So not all the people are represented in these frames, right? Not everyone is.
No, but
because it's a moving camera, right?
Yeah, but on average, I mean, there are at least 10 people per always visible.
Okay. All right. So let's say 10 people per frame. How many people in total can we estimate?
Yeah, 5,400.
No. Oh. In general, you take how many players?
30, more or less. I don't know.
30.
The exact
30.
number. 30, 20, between 20 and 30. I don't know.
Okay, 20 plus the referee, 4 plus public, another 20, let's say. So we have 50 people.
Yes.
And you take 10 over 50. All right? Does it make sense to take 500 frames? Or shall we take less? Because if you have 50 people in total, okay, it means that in 10 frames, you get all of them. Let's say that in 100 frames, you need 50 frames to take all of them. At least once. To see them at least once.
Yeah, but the let's say taking each person more than once could be useful because.
Yeah, of course, of course. Goes without saying. My question is, does it make sense to take 10 observations for each person? Because that's what you're doing here. How much does the position of a player change over time? Does it change so dramatically, the aspect?
You have the front and the back.
Yes, and then?
And all the...
Yeah.
The pose.
All the movements that a player can do. So.
But in the end, let's think together, guys. In the end, what do you want to learn? Team A, the aspect of Team A, the aspect of...
You want to learn the garment, the clothes that you wear.
Yeah, you want to learn the T-shirt, right? The jersey. You want to learn the jersey color, and that's it. That's what you want to learn. The jersey and the trousers. What else?
Basically, the fact, another maybe interesting information is that typically players are bigger than the rest. because they are always on the center of the screen.
Okay. Scale.
Another problem I think is that there are some players or people that are more rare in the frames. For example, the goalkeepers are very rare because they are
Yeah.
only in the in the borders of
Yeah.
the pitch. And for example, instead the referee is mainly always present in each frame.
Okay. All right. Let's say that we go at 500 frames per match. Okay. It means that CO2, let's assume that we need at least 10 poses of the same person. It means a CO1, we take 10 matches, which gives us actually 30 matches, which gives us roughly 1,600 frames, which is 16,000. We said how many people per frame?
On average, 10.
So 16,000 frames. Sorry, it's 16,000 bounding boxes.
Yeah, people.
I think this could make sense. What do you guys think?
As I said, I would be more generous in the number of matches. Maybe we should be more conservative in the number of frames per match, but I think that
Yeah.
the number of matches should be higher.
Okay, so let's put 40 matches or 50 matches, and instead of going at like 6 frames, maybe we can go at 10 frames per second.
Yeah.
Okay.
And you know, what I would like you to think about is this way of determining the number of labels that you need, determining the number of labels that you need, using this as a starting point. Not the data as a data set as a starting point. You start from the problem, you define it, and then you try to allocate your resources accordingly. Does it make any sense to you?